Alright, welcome back everyone to another video, and it's about the new Intel GPUs. They are here, and I don't know how long they'll be here. So I just bought one as a keepsake. I have a bit of a collection of GPUs, and I just wanted to test this one out and see how it works, see how it looks. We'll talk about the performance and the viability of this new GPU later, but I mainly wanted to do a hardware show. I just wanted to open it up, see how the sock looks, see how the rest of the GPU that's hidden from us looks, and all that good stuff. So, starting with the box, it's quite a new, nice. Yeah, it's a GPU box. I like the color schemes. Intel has used this. The newer GPU looks much better. The better ones, the 770s and the 750s look much better in terms of the color scheme and the GPU design. But again, is spending that much on a first generation product that might not have a successor is a bit too much. One of the few things I am very interested in with this GPU is it's something that they don't mention. They should put it in big letters. Is AV1 decoding and encoding, and to use this to record my videos. Like right now, my Ryzen 3950X is at 80% CPU usage because I'm recording a high quality 4K stream, albeit from a webcam, but it's still a pretty good webcam. But it does require processors with smart access memory or resizable bar. Yeah, that's a pain, and I'll talk about that in a bit. Anyways, this one's I think 6 GB GDDR6, so that's actually not bad for the cost. Yep, 6 GB GDDR6. So let's take a deeper look. So they are priced very, very competitively. Apart from that, the performance depends on what hardware you're using. I'll come to that later. So we have 3 DisplayPort, 1 HDMI port. It's a 2 slot design, most of which is just air vent. It has a big heatsink, but that's a non-heat pipe heatsink. It's a big chunk of aluminum, and you can see the BGA ball pin balls there from the sock. The Yeah, it's not a super powerful board, but it's a mid-range, so it's something around RX 560, 570. And something that's a little off about these boards are the power connectors. So even the RX 750 and the 770 have two of these. So these GPUs draw a lot of power, and they require like 300 watts of power supply recommended, or maybe even more. 350 watt or greater with a 8 pin power connector. You don't get 350 watt power supplies with 8 pin power connector. And 8 pin power connector means that you are blowing off the 75 watts that you can get from the PCI Express slot. So this card draws a lot of power. I really need some form of power measurements, but these are probably available online and you can take a look. But I assure you, for the performance they have, they draw an extremely lot of power, because otherwise they wouldn't need this connector at all. All right, enough talking about performance. I really don't want to get into performance right now. I really want to just see the sock, and that's why I've been waiting to make this video and to see how it looks like. Not that it look any different, and if there's any indication from Intel, they don't really mark their embedded SOC. I keep saying SOC. I'm too used to that term. I mean the GPU silicon. Intel isn't known for marking their SoC, so the Celeron board we saw last video had an unmarked SoC, an unmarked silicon chip. I am kind of sadly expecting the same to be the case here, that the GPU silicon is unmarked, but I hope that it is. It always looks nice. So at the back of the board, there's not much happening. Just some bypass caps, and that's about it. A little bit of some chip there. I'm not sure what it's doing. Maybe that's the SPI chip that has the firmware on it. So this connector looks interesting. It looks like what you'd have on an embedded device that would bugger off to an external LCD or something like that. I'm not sure if it's that or if it's just like a debug connector. I'm assuming it's just a debug connector. So let's take the board off. I have unscrewed everything unless I have missed something. It just looks to be a bit well stuck. Am I missing something? No, it seems to be getting off. Oh, the memory pads. Alright, so the memory have silicon pads and they seem to be extremely strong. And here it is, that's the GPU, and the heatsink, as you can see, has the pads for memory. The fan wire is extremely short and there's only, oh, that makes sense, it's like 2 gigs a chip, and then you get 3 gigs, 3 gigs, no, 2 gigs a chip, and you get 6 gigs. I was for some reason expecting 4. Yeah, the wire here is extremely short and it won't come out. Don't want to force it too much. Okay, let me just, the thermal compound is extremely liquidy, and that is weird. Alright, got the heatsink out of the way. Here it is again, as I said, a big chunk of aluminum with 3 pads for the memory. Oddly enough, like only one memory pad makes it to the entire block and the other 2 are just offset. So I mean, yeah, the RAM doesn't get that hot, but it's still GDDR6. So this is the board. This is it. Very much a lot of empty space here and there. Again, even on the GPU itself, like if I put it around here, you can see they do not need this bit of plastic, and they have like holes here on the GPU. It seems like they were planning on a bigger board or something. Not sure what happened. Like they have holes as if the GPU would have screwed in, but it doesn't. It's only held by these screws. So the GPU is only held by these screws, but the PCB has holes here, here. None of those are screwed. One here, and there's like some holes on there. So it seems unplanned, or like maybe they had 5 revisions of everything and they just chose the ones that worked, or something. So like they had like a PCB that would fit on multiple revisions of Shroud, and they just used that. Again, not too much. All the signals for the display. Some GPUs I've seen have chips with the display, so they have either like repeaters or PHYs, because they don't have the entire circuitry within the GPU to drive the signaling of which is not TTL, the signaling of the display ports, but it just seems to be coming out of the GPU directly. And you have your 3 memory chips. There's nothing else. It's a very bare PCB. It's missing a cap. Maybe not required. Who knows? Here's your MOSFETs for power, and there's a power MOSFETs for drawing power from. That's probably something else. But here's our MOSFETs for drawing power from the 8-pin PCI connector, or the 8-pin power connector, and here's a power circuitry that draws power from the PCI card, from the PCI bus. Yeah, nothing much. Let's wipe off the goop and see what's in there. And so, as my disappointed self predicted, no marking on the GPU. But yeah, that's the silicon. That's the Intel Arc chip for all intents and purposes. There's some marking on the side, but nothing on the actual substrate. So you can see some numbers there. right where the light is. And that's about it. That's all there is for, well, the silicon is nicked. That's not me. I didn't do it. There's a little mark on it. Huh. I wonder if it will still work. Yeah, that would be really sad if it doesn't. But I think that was already before the hand, and that's not my fault. So hopefully it works. The All right. So while I put everything back, because that's about what there is to see on the hardware, let me tell you my experience with it so far. So what happened with these GPUs is because they were delayed and then they were rushed and blah blah blah, they have some hardware faults, and one of the major ones is that their scheduler, and this is all like from what I've heard in the news, and I don't have any personal sources on this. Their scheduler is the task scheduler, the hardware scheduler within the GPU is a bit messed up. So, and that's why, like, one of the suspected reasons why it requires the PCI rebar to work that perfectly. Like, it can't work in chunks of 256 megabyte. It needs access. It needs the arbitrary parts of the memory to be updated from the CPU, or like the memory transaction to happen with the entire window open and not in chunks of 256 megabytes, and that somehow messes up the GPU scheduling that happens. So what ended up happening is I don't have a test bench that has rebar support. I have a test bench that's fairly old. It's a second generation i3. And all of my systems that are newer and that do support rebar are doing other important stuff, like being my main workstation, or being in a laptop form factor, or being the things that drive my NAS, or being the ARM workstation I have. So the Honeycomb has rebar support now. It's been enabled. The problem then becomes that that might be too much goop there, but that's no problem. But the problem that happens is I can't properly test it. So far on Linux, it technically works fine. There's no problem with it. And by technically it works fine, I mean it runs GL Mark II and a couple of games and mind test at not that good of a performance. And yeah, it generally works fine. It runs some games good, it runs other tests bad. It runs Vulkan fine, so I can actually use DXVK to run, and this is all on Linux. I can use DXVK to run Windows games, and some of them crash the GPU, and they are specifically games that I have tried on Radeon graphics and I've played through them, so they are stable, but they still crash this particular GPU, and I'm not sure why they do it. And this GPU has ray tracing, so it might be the cheapest GPU you can get with hardware ray tracing support and the ray tracing API is enabled. But currently on Windows, that feature has just dropped to Mesa Master, or unstable, and that kind of only works. I had only like one demo work and the other failed and things like that. So the support's there, it's being worked on. You need a brand new Linux kernel 6, which at the time of making this video released a few days ago and is the latest stable kernel version. That's not a long-term kernel. So you need all of that to have it work in any sense within Linux. So you need a new Mesa 22.7 or better, and you need the latest Linux kernel to have it run anything, even output or display. Yeah, so the resize bar issue makes it have a lot of problems, especially in Windows. On older platform, this doesn't work. I'm not saying it doesn't work as in there's an error, there's a blue screen. As soon as I install the drivers, this stops working. It outputs an HDMI signal that doesn't work on any of my monitors, even the 4K ones. and in general it just doesn't do anything. There's no display, there's no sign of life, it just sits there and does nothing. So I'm not sure what's happening with it, and I'm pretty sure it's not really designed for older systems problem. So yeah, my experience so far hasn't been that good. I hope that down the line I can get the AV1 encoding to work on Linux, and then this becomes my card that that does the video encode and decode on my system. The other problem is ARM support. That might never happen because the folks at Intel decided to use the Intel integrated graphics driver stack to base their work on these GPUs. That ends up being a big problem because that stack's written only for x86. It has a lot of x86 specific um, stuff in there, and that's reasonable because the Intel integrated graphics were only ever shipped with x86 systems or x86 SOCs or CPUs. That means that we'll probably, without a rewrite, might not see support for ARM with these GPUs. So if you're looking at putting this in on a ARM workstation, that probably won't work. And people have tried it. It's a bad experience. I mean, it's a non-usable experience. Nothing happens. This doesn't initialize. It doesn't work. So that's about it for this video. Yeah, I just bought it because this was going to be a unique hardware. Sadly, we'll see if Intel continues the project. But it's also a very good video decoder, and if I can get that to be useful, then it's a good thing, and I can. Um, the other thing is I have a Radeon. I have two Radeon. I have the main RX 580 on my workstation. That's my main hardware. That's my main GPU that does everything. And then there's a little tiny secondary RX 550 or 560 in there that runs one extra display because I have 5 displays. So 3 on the main desk, 2 on separate desks for monitoring when I'm making videos such as this. I have a separate monitor that runs off of that GPU. I want to see if I can use this GPU instead of that, so it does the work of an accelerator, of a encode decode accelerator, and runs my 5th display. That means I can use that RX 560 on other useful places where this GPU won't work at all. So that's it for the video. Thank you so much for watching. And yeah, buy this at your own peril. I'm not going to suggest anyone to buy this right now out of, it's a first gen product, it has issues. If you're running new hardware on Windows 11, then it might work okay for you. Otherwise, I don't think there's a point. All right, bye.